Now, let us discuss some of the important questions of polynomial chapter. First is find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. So, if I solve the polynomial that is x square plus 7x plus 10, I will get x square plus 10 such factor whose sum is 7. So 5 twos are, so I am taking 5x plus 2x plus 10. Now from the first two, I am taking x common, so x plus 5. And from the second two, I am taking 2 common, so x plus 5. So now from both the parts, I am taking x plus 5 common. So in the other bracket, I will have x plus 2. Therefore, x plus 5 equal to 0 or x plus 2 equal to 0. So either x is minus 5 or x is minus 2. Now, if I do sum equal to minus 5 plus minus 2, that is minus 7, which is equal to minus b upon a. And product equal to c by a, which is equal to minus 5 into minus 2, that is 10, which is equal to c by a. So here both the things are proved. Now coming to the second question, I am given find a quadratic polynomial. The sum and product of whose zeros are minus 3 and 2 respectively. So, sum of zeros will be alpha plus beta, that is given as minus 3, and product of the zero, that is alpha beta, which is given as minus 6. Sorry, 2. So, therefore, polynomial will be x square minus alpha plus beta x plus alpha beta equal to 0. So therefore x square minus 3x plus 2 equal to 0. So x square plus 3x plus 2 equal to 0 is the required equation. Now coming to the third question, if alpha and beta are zeros of quadratic polynomial, 5x square plus 5x plus 1, then find the values of a. Alpha square plus beta square, and b1 is alpha raised to minus 1 plus beta raised to minus 1. So Here I am given the polynomial given is pi x square plus pi x plus 1. So if I see pi such factor whose sum is pi and product is pi, so it's not possible. So I have to use the discriminant way, that is x will be equal to minus b plus or minus root of b square minus 4ac upon 2a. So that will be equal to minus 5 plus or minus pi square. So that is 25 minus 4 into pi into 1 upon 2 into 5. So that will be equal to minus pi plus or minus 25 minus 20 upon 10. So that is minus pi plus or minus root pi upon 10. So now if I see carefully, alpha plus beta will be equal to, if I separate the denominators, I can write minus pi upon 10 plus root pi upon 10. This will be alpha, and beta will be minus pi upon 10 minus root pi upon 10. So minus plus will be cancelled. So I can say minus 10 on 10. That is minus 1. Alpha beta will be equal to minus pi whole square minus root 5 whole square. That is a minus b square formula I have applied, and in the denominator I will have 10 square. So that will be 25 minus pi upon 10. Sorry, 100. So 20 upon 100. So that's 0, 0 cancel. So 1 upon 5 I can say. So therefore, now A1 he has asked me alpha square plus beta square. So if I see carefully, alpha plus beta whole square equal to alpha square plus beta square plus 2 alpha beta. Now from this, if I want alpha square plus beta square, I have to take all the remaining things on the other side. So I can say alpha square plus beta square equal to alpha plus beta whole square minus 2 alpha beta. Now above we got alpha plus beta is minus 1. So minus 1 whole square minus 2 into alpha beta is 1 upon 5. So I can say 1 minus 2 upon 5. If I solve it, do the LCM, 5 minus 2. So this will give me as 3 upon 5. And B1 says alpha raised to minus 1 plus beta raised to minus 1. That will be 1 upon alpha plus 1 upon beta. So, if I do the LCM alpha beta plus alpha in the numerator, so again minus 1 upon 1 by 5. So that will be minus 5. Now, fourth question says, if the zeros of a quadratic polynomial, that is x square plus a plus 1x plus b are 2 and minus 3, then find the value of a and b. So here sum of the zeros will be equal to 2 plus minus 3, which is equal to minus of a plus 1. So therefore I can say minus 1 equal to minus a minus 1. So both sides if I cut minus 1, so minus a equal to 0. Therefore a equal to 0. And product of the zeros will be equal to -6. So 2 into -3. So that is -6, which is equal to B. So therefore B equal to -6. Therefore I can say A equal to 0 and B equal to -6. Now coming to the fifth question, it says find the zeros of the quadratic polynomial 2x square minus in bracket 1 plus 2 root 2x plus root 2 and verify the relationship between the zeros and coefficient of the polynomial. So here 2x square minus 1 plus 2 root 2 x plus root 2. So if I open it, I will get 2x square minus 1x minus 2 root 2x plus root 2 equal to 0. Now if you see clearly from this 2, if I take x common, so I am getting 2x minus 1. Same way, if I take minus 2 common from the rest 2, this 2, so I will get 2x minus 1 equal to 0. So 2x minus 1 or x minus root 2 equal to 0. So either x will be 1 upon 2 or x will be root 2. So now sum of zeros will be equal to 1 upon 2 plus root 2. If I do LCM, I will get 1 plus 2 root 2 upon 2, which is equal to minus b by a. And product of zeros is 1 by 2 into root 2. So that will be c by a. Hence proof. Coming to the sixth question, it says the number of a polynomial having -2 and 5 as its zeros is a 1, b 2, c is 3 and d is infinite or infinity. So we know that if I solve this, so I will get one common equation that will be x, x square minus sum of the zeros. So -2 plus 5x plus product of the zero. So -2 into 5 equal to 0. So this will give me x square minus 3x minus 10 equal to 0. Now this is one equation, but if I multiply it with different variables, that is if I multiply all the three with 2, I will get a new equation with the same zeros. Similarly, I can go on for till infinity. So my answer is infinity. Now, seventh question says a quadratic polynomial whose zeros are 2 upon 5 and minus 1 upon 5 is. Now he is asking me the equation to form. So A option, B option is 5x square minus 2x plus 1. C option is 5x square plus 2x minus 1. D option is 25x square minus 5x minus 2. Now, if I solve for this, so sum will be equal to 2 upon 5 plus minus 1 upon 5, that is 1 upon 5, and product will be 2 upon 5 into minus 1 upon 5. So that is minus 2 upon 25. So therefore, quadratic polynomial formed will be x square minus alpha plus beta x plus alpha beta equal to 0. So if I put the values, x square minus sum is 1 upon 5x plus minus 2 upon 25 equal to 0. So now I can't keep the denominator. So if I multiply everything with 25, so multiplying the numerator with 25 will give 25x square minus 5x minus 2 equal to 0, which is the required equation.